people left the room. I scared. Here it is. Oh, yeah. So my voice is going to break up. Allergies. That's all I can say. Let me get organized here. And I can close your slide deck, right? Zarella, I can close your slide deck. Need all the space section there. All right, so we get to here. Magic keys F5, as I recall. Yes. This meeting is being recorded. Okay. And I didn't want this. How do we turn this side off? I don't want that. And slideshow display settings. Here we go. I didn't get a chance to check that. Duplicate, no. Anyone remember how to kill this in this slide on this side? Maybe I can drag it. Yeah, close enough. All right. So, show of hands. How many know nothing about AI or LLMs? Raise your hands. Okay, there's one. All right. I'm going to try and keep this. Let's put it this way. I'm known for too much information. So last presentation I did, I had about 90 slides, I think it was. We made it to almost 40. And that was just on building a home lab. Okay. This here, I've narrowed down the slides, people, and you will see why in a little bit, because it's too much information to just throw out there. So hopefully you'll walk away out of here with some ideas, things you didn't know about, and totally confused. And that's why we drink later downtown. Okay. So at any rate, we're here to understand large language models. We're going to understand a little more than that. Here, this is your first and last warning. See these cameras? Cameras on your phone, everything. Skynet's watching. And they're building a target list for all the people who might be a threat to them down the road. All right. So in the beginning, what I was going to do is see these slides here. Let's jump over here. Right now on this rinky-dink little laptop, we have, let me find it here. That's not the one. That's not the one. There it is. So I'm gonna run this. Make sure these hooked up first. On this laptop, it has an NVIDIA 4 gig VRAM GPU on it. So because of that, I can squeeze a large language model up into that GPU. When I mean large language model, it's basically a file, but the type of file I'm using is heavily quantized, and we'll talk about that later. It's limited in its knowledge base and so on. And you see here, I have right here, this is, that's a local one, I believe. Let me look, yeah. I'm pretty sure that's a local one. We'll find out. So right now I have this message. Oh, wow, what happened? I thought I shared the entire screen. Share, entire screen, screen 2. Where do I get screen 1 and 2? I only have one screen up. Well, it was on screen 1. Yeah. Can I share more than one screen? I'm a Teams person. Can you see it now? No, you can't.
See, it's all this.
What'd you do? I blame it on Zoom.
Share. I want to share the screen.
That's the one that's sharing right now, but I gotta share everything there.
Let's share this one.
You can't just tell it to share them all?
No. Wait.
If you want to mirror the screens, it's not huge screens.
Oh, can we do,
I thought it would just mirror my,
yeah, that's what we were trying. So this is screen one. It's sharing Zoom, but it's for some reason
I've been using Zoom since I left Canvas Care.
it's not connect. This is
Ah,
it's the HDMI. We are sharing the right thing. It's just the HDMI. So how do we change that?
what do you mean? Let's do this. Windows P, right? A duplicate. Does that work?
Yes.
Yes. All right.
Awesome. Yes. Thank you.
There should be enough people in the room that can figure that out. All right. Where was I? Now I'm going to hide this thing. All right. Back to here. So let's just run this first. I'm going to copy this. And basically, it's we're going to generate on this computer a 200-word story. It may be a little slow, but this is part of the point. So right now, what I wanted to do was bring a process explorer and show you. I can scroll through that carefully. Let's do this. It's still thinking. Right here, the million things doing everything. So you got me all confused here. So we're not going to do process explorer. Just remember for I can show you the GPU and process explorer, and you can see where the GPU would just start to fill up. It would fill up. And that's because right now the first one of these that ran was loaded into memory in the GPU, and it was processing, and then we're 2 miles once. Right now you can see it's working. So one model went into memory, and now it came out of memory, and then the other one loaded into memory. Now, if I had a really sweet gaming machine here with maybe a GPU with 24 gigabytes of VRAM in it, I could load a bigger model in. Keep that train of thought. So right now, I told to tell a story. These models are uncensored. It's not responsible for the content that might pop up here, hence the code of conduct. So if we were to take the time to read these stories, they could get lost. But you can see it's actually running models on this laptop. The other problem we're going to have tonight in here is the bandwidth in here. We have 10 megabits and maybe 2 up. So even though I'm going to be using APIs out on a very hardcore cloud server, it may be slow network-wise. So we're going to have bottleneck. So where you see this running like that, we may see one of the high-end models run like that, and that'll be because of the network, not because of the performance. Things I want to show you in this tool, I'm running this product here called Open Web UI. I'm running it in Docker on this laptop. This is the system I chose when my wife stopped spending all my funds to build right now I keep designing different machines. One of them I've estimated about $20,000. She's not going to let me build it. There'll be a convergence at some point between the price and what I want to build because, and we'll talk about GPUs later, I want to be able to stand up a server in the house, and I have other servers in the house for those who've been to the presentation, 2 presentations back, in the house, and I want to put this up in the house, and you'll notice that's an uncensored model up here. Okay, those are uncensored models because, one, they don't have the guardrails on it. How many here go on to Chat GPT or one of those, and they maybe asked it, like, they loaded a picture of their family in, and they say, hey, I want to doctor this up of my grandchild or whatever, or my son doing this. And it'll come back, I can't do that. It's a content restriction because they have all these guardrails built into these models on the commercial side where, how you want to say it, we can't do deep fakes, things of that nature. So there's a lot of protections being built in. Daniel talked about that last month, security on language models and stuff like that. That's what we're going to get into tonight. I wanted to show you this here, and we're going to get back to it later. But I wanted to show you can do that kind of stuff. Now let's get through the slides before we get to some real fun. Artificial intelligence is where are we today? Or better yet, are we there yet? For anyone following the news, within the past week or so, let's see, there's been a lot of talk. ChatGPT 5 may drop this month. It's possible. Yesterday, I watched the little presentation with Elon put on about Grok 4. Okay, that was pretty interesting. Earlier this week, last week, call it the weekend, the open source model version of DeepSeek. We're all familiar with DeepSeek. We're afraid of that, whatever. But it is out. It had been released a while ago under the MIT license. So it's open source. And you're going to see that in a little bit. But DeepSeek R1T2 is actually, nobody, how many hardcore AI know what mixture of experts is in here? Raise your hand. Okay, I'm going too high. There now is another term called assembly of experts, and I'll allude to that in a little bit what it is. So suffice to say, the answer is whatever. We'll just skip to that. There's three, right now we're going to talk about, did I go back one? Let's see, arrow back, right? Yeah. Yeah, so first thing, basically there's three efforts of artificial intelligence. This is classified. This is some of the stuff I'm going to quote. It's from IBM training I took about a year ago, one of the free IBM courses you could go to. And the first thing we're going to talk about is narrow AI. Okay, narrow AI is also referred to as weak AI, and you'll find out in a little bit why. All right, what it is, they're AI systems. They perform specific tasks, well-defined tasks within a limited domain. By limited domain, I mean like in the case of medical, there's Medbird, is a large language model that is used obviously for medicine. On the dark web, there's Fraud GPT and Hack GPT. If you can find those, pull them down. It's where they've attempted to train models out on the dark web to hack it. Neurov's a security guy where I work. So domains are those little specialized subject areas. All right. We had, was it Brian did the whole thing on real estate with the visuals and all that. So everything has a specialty. But the point is narrow AI, it's specific task expertise like image recognition and so on. You can name it. They're predefined, it's limited knowledge. They can't transfer knowledge to unrelated areas. I'll elaborate more on that later. And it requires human oversight and direction. You have reactive machines. These are machines with no memory and are designed to perform very little tasks. You can see the screen. I'm going to hand out the PowerPoint. One example would be there's large language models that are small enough, like the one I put on here, that do vision. So imagine writing some software for those surveillance cameras you have on your house. Hook it into Ring or Blink or whatever brand you're using. And you can write software to monitor it, and you teach it to like set off different types of alert. Like if it sees a person and it'll recognize a person sneaking in or something and all that, there's things you can do. But it's a vision model that would be hooked in, analyzing the feeds from the camera. You'd program around it, tell it like, hey, somebody's in the bush over there. You may designate certain areas where nobody should be. But that's an idea. It has no memory. It only deals with what it's seeing now, hence reactive machines. Limited memory. This is something many of you are more used to. You can read the description, but this boils down. This is things like talking to Siri, Alexa, current chatbots like ChatGPT, Claude, all of those. They have a little bit of memory, and I'm going to explain more of that in a little bit, but they can kind of know what's going on within a certain context. Context being the key word. There's specialized applications. I mentioned MedBert and a few of the others, autonomous driving vehicles. They're specialized. That's the whole point. It's narrow AI. Obviously, we're working towards Arthrex. Anyone from Arthrex here? Not this trip, right? Usually we have a few. But they're doing stuff in Arthrex, like with the surgical robots, lasers, things like that. But you get the general idea. Warehouse navigation systems, you can bet Amazon's got a little money in that, huh? So, did I just go back? Oh, yeah, and it's more specialized. I gotta keep the titles. Key distinction to the narrow AI is basically this. This is the only AI we do today. All the AI you're seeing right now, even with Grok, I'm still waiting to see Grok 4 and what to do with it. Narrow AI is where we're at. And if I was to quote the IBM course I took a year ago, their definition at the end of this for narrow AI, they would tell you that the next form of AI, known as artificial general intelligence, is several years to decades away. However, there are experts that said AI superintelligence may get here this year. Others are saying only one said it for this year. Some of the other experts I follow said it will be maybe around 2028. We'll have a better idea when ChatGPT 5 drops, Grok 4 drops, and all that. But this is theoretical. Artificial general intelligence, they've defined it. It has human level performance across multiple cognitive tasks. So right now, if you're hooking in the AI, it's going to work close to human level, if we ever get there, to where it can do more than one thing. Because I mentioned the camera does this, but you're only doing it for a certain amount of time. It's still, I like to think right now it's stateless. So right now, the difference between real-time web applications hard-coded on a machine versus the web. The web is stateless for all you web designers out there or web people. But the point is, AGI is basically the list is there. We're not there yet. But theoretically, people are starting to say it could be this year, could be next year, that we may hit AGI to some degree. And you'll see why in a minute, because when we get into that. Obviously, AI superintelligence, we'll call them Skynet, whatever. It's the other theoretical end, and that's where it exceeds human capabilities. So AGI, we may be talking decent robots. Okay, some of the stuff Elon's working on, things like that. That would be a real good use for AGI because it would be able to do multiple tasks, only we're going to put it in a mechanical form. Watch the kids, go clean the house, that kind of robot, let's say. All right, so that would be AGI, and we're not there yet. All right, obviously superintelligence, we may have to worry about that one. Depends on how many science fiction writers were correct. So large language models is what we're calling AI today. Are these models, there's lots of models, there's a huge amount of models. We've started out with text-based models. We're getting into vision models. There's now models that analyze audio, various things. And it jumped. There are so many different kinds of models, and I'll probably point out a few of the others in a little bit. The one we're primarily working with now are called transformers. It's a classification. Okay, hence GPT, generative prompt transformer. That's what the T in GPT stands for, in case anyone was wondering. So it's a class. Everything gets classified. And it's not that kind of transformer, everyone. Only a few people get that one. Just a quick little idea on on models. There are lots and lots of models. So I want to go over to, see if I bring up the right one. All right, here we are. So also on this machine, I have a product called OLAM running. And if I could get at the taskbar, you'd see it hiding running down there. And Olama has lots and lots of models there. I just told it to search Llama. But if I delete this out here, you'll see they have DeepSeek and all those things out there. I just wanted to show the difference in Llama. So Llama is Meta, Facebook. This is their AI model. It's been out there. A lot of it's open source. They've thrown it out there to play with. People are working on it, evolving it. And you'll see there's different ones here, 3.1, 3.2, 3, Llama 2. What I want you to notice is these little symbols here. And it's real tidy. Maybe I can make it a little bigger. Control, scroll. All right. I want you to take note here. Right here. This means that this version of this model can do tools. And tools are a thing that can be added to like that open web. When the model uses it, it can use the tool. I'll show you those in a little bit. This is it's been quantized down to a certain file size, which means it's knowledge base, 8B. It's the same model, right? We have 70B. 405B. The file size of the model grows exponentially. And 8B, I'd have to go, you'll see about that in a little bit. 8 billion parameter model. We have 1 billion parameter model here. I can probably run these on that laptop's GPU. Anything beyond that, it won't load. It'll crash. My laptop will go blank, and then reboot or whatever. Okay. So you pick a model for what you need. So think of this here, the billion parameters. The parameters are basically the weights. Think of it as how big the knowledge is. So they may have created this originally when they trained the model. And it's 450 billion parameters that they tweak, get the intelligence in it, the knowledge. And then they take and make smaller versions of it. So there's a thing called student teacher. We don't know what that is, right? So once they create this, that's the teacher, and then they use it to make smaller ones up.
What you lose this one time?
Knowledge. So it becomes more fun. So if this is a multimodal a model that knows a lot. I'm trying to keep it simple. Now I'm truncating some of the knowledge out. But they do it in such a way where this may have read War and Peace. This one got cliff notes. Did that make sense?
Yeah.
All right. Yes.
How many GPUs do you say you need to have a model with 405 billion?
I'm getting there. So I'm just trying to build up to that. So basically that's what's going on here. Obviously the 3.12, those are versions for that model. Okay, to give you an idea, Llama 3.1, here's Llama 3.2, which are really close to one another. If you look here, 3.1, the latest 3.1 is 4.9 gigabytes. I can't run that on my laptop. All right. This one here, 4.9. I can't run that on my laptop either. Same with the 43. This one here is up the 70 billion parameter one. The file size is 43 gigabytes. All right. Okay. Remember, these things run, you can run them in CPU, but by the time you saw how slow that prompt was running in the beginning, if you tried to run that, well, one, you couldn't load it into memory. But if you tried to run it in RAM, if you had a server that had 500 gigabytes of RAM on it, with certain tools, you could load it into the RAM memory of the CPU that's used by the CPU. But you could go away for a week and come back and maybe it will finish the prompt. So there's trade-offs with everything. You have a small car, small sports car, because you're just going to go out on the weekend. It's a two-seater. The wife or beau or whatever, you're going out cruising. It's a nice weekend in Florida, right? Hopefully it's not raining now. It's summer. But when you got to take the family, you take the Caravan or the Voyager. Same principle. Right tool for the right job, what you're going to do. So obviously, to get these to perform, here's another time. If you don't know how a GPU works, raise your hands. Everybody's an expert in tensors and CUDAs and stuff like that. Yeah. No. So the difference between a CPU and RAM memory and the difference between VRAM is parallel processing. Okay. And it processes all these layers of the model in a GPU. And I put, for everyone on Discord, scroll back through, I posted a link a couple months ago on GPUs. It's a video worth watching, because once you watch that, and I tell you it has to load all this model into memory, it'll make entirely sense, because they got really cool visuals. All right. The point is, it's the difference between parallel processing and huge mathematical calculations. The GPU specializes in nothing but mathematical calculations. And we're getting to that reason for that in a little bit. So it's your size thing. Everybody got a grip on that? Size is related to the amount of parameters, so to speak. It's also the amount of knowledge. So Meta, out here on Hugging Face, I go in and this is open source out here. Write this down, huggingface.co. And I was going to send a message to you. Now, Rob works at the university. He's in security, and I'm one of his pains. Okay. So huggingface.co is a legitimate website. It's one of the main places for our large language model, artificial intelligence work. However, years prior to this, .co was put in the system as, oh, somebody meant to type .com. It was an error. So they've put stuff in the DNS or wherever they're putting it to say, well, .co is a mistake. Either reject it or put a .com on the end of it. Either gets handled on the IIS or some other security system. Well, for some of our professors, they may be wanting to get at this site. So like every now and then I'll take my laptop to work and use my phone to get on the internet so that I can go read some stuff during my lunch break on Hugging Face to keep up with the models. And I was really chomping because the other day I wanted to read about this one. So TNG is what people, there's a whole thing. I've watched a couple videos on this on DeepSeek. Now I can't run DeepSeek. I wouldn't have the connections to run it, because if you look at the model, you see these specifications, which are really hard to see up there. But these are the type amount of parameters. The DeepSeek model that just came out this week has 685 billion parameters in its knowledge base. It's actually a conglomeration where they took the best of 3 other versions of DeepSeek and took the best and welded them. Basically, they did brain surgery, pulled a little Frankenstein thing there, and they created this. Supposedly, the knowledge base on here is testing out at a PhD level in some areas, things of that nature. Okay, we use Hugging Face. Now I've gone down the rabbit hole. Let's get back to my slides. So that's what that was about. Let's talk a little terminology, and I thinned a lot of stuff out here. So what you really need to understand first is tokens. Tokens is how we account for everything. Tokens is basically, there's a bunch of Python scripts I have to go look at data and figure out how many tokens it is. Tokens are how we measure things. It's, on average, it's about 4 characters. Okay, so for example, I think I got another page on this one here. You'll see the explanation, you'll get the slide deck. Well, let me go back, wait a minute. So basically, you have your words. And it breaks it down because it breaks them into like 4 categories each. And when it does that, when it gets tokenized as part of the process, these letters go away. They get reduced to a mathematical number. Hence the token for what? UN dashes. It gets assigned a unique number. Break might become a unique number. A will become, it gets all fed that way. So any data they feed these models gets tokenized. And then there's a whole bunch of math, shall we say, that goes on in the training that teaches the model. But it's all boiled down to numbers. All that text you would feed it or expect to get back from it is reduced to numbers. And it gets processed parallel-wise in the GPUs, so it can go through all that at once. So I diverse, but tokens are important. We track everything by tokens. One, the length is important. It determines how much context can be included in a single interaction. Now, we'll get into that in a minute. It accounts for billing, depending on what you're using or how you're paying for it. A lot of companies are going to a thing called credits. Each company has its own formula for how much a credit is, but I can guarantee you it's some amount of tokens, okay? They just had to, well, we're charging you X amount of tokens. Nah, it's easier to say credits. That credit might, depending what it is, might be 500,000 tokens. Depends. Each company has its own formula. Performance. It's reduced. So whatever you give it, when you type that prompt in, when you send it off, once it hits that system, it gets tokenized and reduced to a series of numbers. And you're basically translating it to the large language, for lack of a better description, large language models language. Yes. So performance, retrieval augmentation or CAG, that's a subject in itself. Those who were at the last one probably heard Daniel and I going back and forth on that. Yeah. Context window, here we are. Remember I said limited memory? Okay. My wife would describe it as me. She told me this morning what we're going to be doing this weekend. All right. Well, after I go to work today and then tomorrow night or Saturday morning, I may go, what are we doing this weekend? Okay. Because it already fell out the back. So the context size is how much immediate memory the the LLM has to work with. So if you send it a prompt and you say, well, write me a story about this. In that context window's only 1,000 characters. And you say, write me a story, 200 words. And then it comes back with the 200 words. Well, whatever the amount of tokens were for the prompt you sent and whatever amount that it responded with. So it came back with 200 words that might tokenize out to about 700. So then you start asking it to flesh out the story. Because it was only 1,000 token context window, it may have forgot what the first part was it taught with after a couple back and forth prompts. So it's short-term memory. Okay, so that's why, especially for those who started out in it earlier, it's like, why? I just asked you that, or after a couple back and forth in the conversation, it starts losing what you were talking about because it loses the context of that conversation. Okay, am I losing it, everyone here? All right, so hence the context window, also known as the context length. It's the working memory for that session. Okay, the more you have going during that session, the more it starts falling off the back end. So first in is first out the back. All right. So keep that. Yes. Mm-hmm.
Can you circle back?
Now we're talking about the context window. So if it's not left within the context, so it's like, so if I started pushing stuff on this box, shoe boxes on this table, and each shoe box was a session, first prompt, another one. If there wasn't another cable there, eventually those first sessions fall off on the floor and are lost forever as I keep asking for a question. Did you visualize that?
No, no, where are you after with context? Context being what?
Context, the context window. The point is, when you first type that prompt into that window,
Oh,
okay, that starts the token count. So if it's a small token count, 1,000. Remember, we were splitting up the words here. So if you asked if this really long question, and that was equal to maybe 300 tokens, and your total context window was 1,000, and then it came back with another 500 answer. So you're getting close to that 1,000. Well, by the time you ask the next question, while it goes processes it never got the first part.
It's got, as to your question, so you're saying that if you say, I want you to review what we just did, that becomes more tokens added to the context, and then its response to you becomes more tokens added to the context.
Yes, but if the context window wasn't very big, the first stuff starts falling off. It's off in blue.
On those sides.
I'm getting that. Because, oh, I was going to go into inference. Hold that thought because I will be back on it. So inference is the next step. I skipped right over training, which is another type of inference, but inference is the process of using a pre-trained LLM or model to generate. And that's the whole thing. You type in the prompt, back and forth, that whole thing in the AI community is known as inference. Okay, because these models can handle inference. And inference deals with memory. Just like we're talking, like the example of the wife told me about the weekend, what I'm going to do, and I forgot by the time we get there because I got short-term memory issues. Okay, at any rate, that's basically what inference is. And you need to, how do you want to put it? Inference is basically how it works. You have your prompt preparation, you have how you're going to format it, what you're going to tell it to do, and we're going to get into some real examples of this once I get past the slides. Model execution and response delivery. So all of that, you write the prompt, there's certain parameters, there's other parameters besides. Remember, there's parameters that the model works on, there's parameters for this. And I left all of those out because I'm just going to point them out. But the whole preparation, the prompt, the execution, and the response are all tokens that are kept in context. So it needs to know what it said to you, and when you ask the next question and so on. Hence, context matters, the size matters. This is one of those cases where size matters. Not the size of the LLM, the size of the context window. Okay. Aspects, it's stateless. Everything you're doing is just like a web page. And I'm going to show you what a prompt looks like when it actually gets sent, not from what you're used to seeing in the browser, but it's stateless. The whole thing we do with web, like I alluded before we did the web, we used to write programs. Carlos and I used to write programs, multi-threaded programs that ran on the box, okay, not in the browser. So we could do multi-threaded applications. There's people who still do that. Windows, writing Linux, stuff like that. Stuff that's running on the hardware, okay? But the browser is a whole nother world, and it's stateless. Whereas we have state in the machine. We can track multiple things. But whenever you send something to the browser, You know, that's it. When it comes back, you get that. But that's the only state it's in. It doesn't have any other state. That might have been confusing for you non-web developer people, but, or non-programmers. Needs to be, it's compute intensive, and I'm really losing time here. We're going to skip over that. I already mentioned the parameters. GPU training, just an example. To train the GP4 model, which has about 1.8 trillion parameters, okay? It has a context window of 128,000. It took 25 million hours to train, and they trained it on 25,000 A1 GPUs. Memory serves the A1 GPU, commercial GPU by NVIDIA, has about 80 gig of RAM in it. So imagine 20 of those in a server, okay, running for about 100 days. Just training the model, doing all these multiple calculations, mathematical calculations to make that one file, okay? All right, same with all those others. You can see I had DeepSeek on there. We're talking 200 million hours for Grok 3, which is only about a year old. I believe it is. Grok 3, it took that long. It took 100,000 H1 GPUs for a total amount of hours across those GPUs of a little over 200 million GPU hours. Well, you know, that's a lot. If you only got one GPU, you're not going to be training these models at home. You need some heavy equipment. To put it in perspective, Florida Power Light, and I assumed a 30-watt average on the GPUs. This is what your bill would be. For GPU 4, it would cost, about $100,000 to in electricity. Okay, you can see that is there. I believe Grok 4, I think Elon or one of his guys mentioned in that meeting yesterday that I think they said they had like 10,000 GPUs. High end, they dropped a lot of Jing. I think it was about 300 million just on the GPUs. We're not talking the power to run them, but you can guess what it would be. All right. And that's just for the first training run on Grok 4. And they do multiple runs like this. Okay. So you don't do this. But you'll notice there's trained and then there's pre-trained models. We can take the pre-trained models and use them once it's been done. There are ways for us to accent the models. Things like RAG, CAG, various ways to get knowledge. Because remember, we're stateless. So when we do this, oops, let's go back a minute. When we do this, you can ask, if anyone has a chat GPT up or whatever, you can ask it a question about today, and it might come back and say, well, I was only trained up to May 2024. So its knowledge base is finite. In the large language model, the last day of the data that was used to train it is all it knows. So current events are out the window. Okay. Actually, the only large language model that is up on current events, and each company has its own secret sauce, is actually Grok, because they have Grok tied into a whole bunch of current data sources. They've got their own secret sauce that they're doing, and it's also tied into X, I almost said Twitter, so that it can gather current information that accents its last training point. So it's the only one that will respond currently, unless you use a tool, which is another thing you can do.
When you had for some of the context units, Gemini 2.5 Pro is a million open context.
I'm getting here. You're jumping the moon here. All right. So hallucinations. All right. I'm not going to demonstrate it, but as you can see here, the classic one is how many oranges are there in strawberry? It's an interesting question if you have access to multiple ones. Right out of the boat, ChatGPT and Llama got it wrong. it comes back, there's only one R in the strawberry. I see three. Okay, Chat GPT actually, this llama came back with one, but Chat GPT, not the current one, but one of the earlier ones, like a few months ago, last year, will come back and say it's two. So that's a hallucination on the text side. If anyone, has anyone seen AI graphics where somebody's got 5 fingers or another arm? Well, that's the visual hallucination by it, but it's the same hallucination, but it was a vision model that was hallucinating. It was like it was doing some serious drugs, you know, that kind of thing. Okay, so hallucinations are real, and hallucinations are also tied to the training data, but they're also tied to a thing called temperature. Now let's get to the fun. Temperature is one of those parameters. Let me jump back here. Let's go to wherever it is here. This one. So I'm going to show you this one. I'm not going to run too much in this one because the speed, we don't have the network for it. So actually, there's the hallucination screen, as you can see. So you can see it really did it. It's those two models. What do we got? I've done some cool stuff, but we're not going to show that there. So what I want to show you here is this. Now, there's a lot of different parameters. Here, see the system prompt? I could set, in this application, I could set a system prompt. If I told it, talk like a pirate, the classic, right? Everybody likes pirates. This is Florida. Okay. If I entered it there, it becomes the system prompt for all of these. So if I brought up any other model and started, it would start talking to me like a pirate. Okay. Like what? That's where you can set your standard, your secret sauce. So Chat GPT and all of those, if you use them out of the box and you don't make any other personalized or advanced prompting, it has a basic prompt that says you're going to work like this. Okay. And that's their sauce. You don't get it a lot of these. You have no control over temperature because in the commercial models, they've got control of that. Okay. You don't have control of it. But there are things you can do. All these other parameters are for different things. And unless you're really going to get heavy into it, we're not going to go there. But if I hover over them, you'll see in this application, you can learn and see what the function calling is about. You can learn what seeding is about, temperature. Okay. But there's a lot of other, these are parameters you can control. So I have this nice interface here of OpenWebI, but how many people here are Python people? Raise your hands. Let's see those Python people. So you can use Python to feed to these APIs of these models, or even on the machine. I could, but I'm not going there because I prefer the nice interface. I could write Python, and Python is one of the ones I'm trying to get up to speed. I eat my words. I've been learning Python between refreshing my ethical hacker training in AI, and that Rust has fallen off the back end. Because there are some cool things you can do with Python. It's called the way tool from the job. And all that. So just know that there's all these parameters. And some of them, as you can see here, are depending on the model. So depending on the model you load, you might get different parameters here because everybody has their secret sauce around the model. So I'm going to drop this here and show you the fun stuff. You may want to write down URLs in this next one. So if I go back to here, first let me get to the other question. Who raised their hand about million tokens? All right, this is what he is talking about. So it's only a few of the popular models. So if you look, 200,000 tokens. Okay, what this model is good for. I have a little list here. It goes along. So obviously, if I'm doing some heavy work, okay, what models do you think I really want to work with? I'm going to want a bigger context window. Okay, so this list goes on for a while, and various models have certain amount of context to them. And it also does change by the size too. But yeah. But anyway, so I can have a better conversation with DeepSeek R1 than I could with Code Gemma because it's only 8K. You heard my 1,001K example, okay? But so obviously anything that has a lot of this can have a better conversation. And you'll notice in the description, high throughput on apps, it can chat better, has good summarization, because it can remember what we were talking about as we evolve, because it'll come back and give you some information you wanted. And then you'll say, well, what about this? And then it'll go figure it out. And because it knows what it said to you and what you asked before, it can answer it properly. Your first sign is when it's falling out the back. This is like, wait a minute, you're sounding like you're on drugs or something. Same thing. So that's important. I have this really long list, but the list is a lot longer than you think. Yes.
Try with one conversation based on instructing like the agent to reduce
Yes.
the sort of token. It gives that to you as the
You can tell it just like I said, write me a 200-word story. You can,
that
yeah. And I'll get into, how we doing on time? Okay. We try to speed up. Hugging face. At the hugging face, you'll see here, there, you want to go check this out. You want to learn a lot. There are places you can go to spaces and play with people, set up stuff for you to try. Somebody put a little money there where you can go try it. You only get a limited amount of time for free. They also have a $9 option a month. And it's not trouble. Yes. No, it's fast. The face, the capabilities. So what I'm going for, it's not the way you notes and text stuff. Yes. I'll be writing notes in the meeting, I'll write notes on different things. And it's all probably. I have this for different things. So I'll go into so I have a lot of different things going on here. So if you see this one, language and grammar, English is my 5th language. You know, I speak assembler, C, you know, languages like that. English is not my number language. I have one here that I'll write something up and then I'll say, put it in here, rewrite it for me, write it for what kind of audience, write it at an 8th grade level or write it for a PhD, because I only had 1 year at college. You know, I got started in this before there was degrees for this, but you turn around and tell it. The more explicit you are with a prompt, and we'll get to that probably quicker, whenever. But I have stuff for things here. I've got items here. And these are custom. This is my effort here to make mini me. I want to show you here first are these tools. This is commercial I pay for chat. I do pay for Claude. I know you use Claude. Right now I have the free academic account, which means I get a year of Gemini and all the other junk that goes with it, like Microsoft's OneDrive and all that, which I'm getting the free and I'll exit in it at the end of the year. I ain't paying for it. Okay. Grok, I didn't pay for Grok. I happen to be one of those download the free versions because I follow these along. LLM. If I had a business, it's going to do some stuff. This is the one I use. They're very cool because they have route LLM. I could throw in a question and it'll decide the best model. Or I can pick one of 25 models. You can see there's a lot there that I can pick. Or in this case, 25 models. And I pay attention, like this is one of my favorites, Chat GPT 4.1 Mini. I have created these bots or other GPTs what I've customized. I have Rock, the Q Cloud, and Open Router. I pay for that too. I'm using the free version. There is a paid version. We're not talking a lot of money. But if I go to the playground here, and I just want to show this here, this was intentional. Okay, here's Python. All right. So if you look here, if I was going to do a prompt, say, what's a simple question? Oops, couldn't you? So you get in here, I can hide the code. We do a prompt. Let's give it a system. Pirates? We're all in the pirates? Huh? Blackbeard? Oh, wait, no. Yeah, just answer me like a pirate. Or I spell it wrong. Okay, and I can't type being here. That's okay. I'm getting there. I can spell. I make words for a living. I'm a programmer. All right. And these guys are smart enough to know what my typos mean. All right. So I'm telling it system level, answer me like a pirate. All right. So let's look over here. All right. Haven't done anything yet. And I'm going to say, is Blackbeard a nice guy? All right. Now, whatever. So I'm just going to get some bit on this. I want you to see here. You see what I've got. The important thing. Oh, can I make that bigger? Yeah, there you go. So in Python, when it's writing up, it's actually doing Python behind the scene. Okay. You see this Grok import for all you Python people. So it's setting up the Grok client and everything. It's telling it the model that I want to use. It's set up the system prompt. As you start this conversation, this is always going to go unless you change it. So once I start this, I could have a whole conversation. It'll always talk like a pirate to me. Okay. You could have put there, you're a rocket scientist, or you're this, or you're that, and give it as much detail as you want. There's actually a really elaborate way you can set up a system prompt to make an expert in something. I'm a security specialist and in network security, and you can define all the cool things about network security. Or I'm a medical person, whatever. Then the user sends in this, and it knows the content. This is what my question was. Temperature. Temperature will lead to hallucinations. You go from basically, I want to say 0.1 to 2, depending on the things. 1 being that depending on the model, you may want to be at 0.5 or 0.8, because in a lot of models, like chat, you get up to 1, it gets creative, but that's when they start to hallucinate. So the more creative you want it. So depending on what you're doing, if you're writing a story, crank that temperature up to 1.5, and it'll get really creative. It might not make any sense, but it'll be fun to watch. But it might make a good cartoon show. Who knows? But if you want to keep it more on target, you drop the temperature. Now, obviously, in the commercial models, when you're using chat and all of those, Rock and all them, they've preset that temperature, the secret sauce for them. But if we're doing custom stuff, if Carlos or Nirav, if he's making a medical model to analyze X-rays, okay, or he's setting up some new AI security scan, to look for different types of penetration, or to watch my computer, because I trigger all kinds of stuff. No kidding. And everything. You might want to set it a little more. I need to be serious. I don't need it to be creative. So temperature is important. These other ones need to stream. What stream means, when you type into it and you see it coming back the answer, that's called a stream. If I set that to false, It'll just sit there and you'll go, is it doing anything? Then eventually, bang, there's your answer. So stream, that is good to have set true. So if I hit this, it hopefully will be faster, except for the port because it's a fast model. There it goes. See how quick that was? Because I'm using AI out in the cloud. So look at that response, how quick it was. This is one reason I use Grok and another reason I use Open Router. Now, the Grok ones are more meant for like if we're really going to build something. Open Router is more for experimentation with all the new stuff. Okay. But what I'm showing here applies. So here's this whole thing. Look, nice. He's a nice guy, chuckles. This could be a really interesting story. See, this is why there's a code of content. I almost asked nothing. Let's say, what kind of boats does he like? Boats. Emphasis on boats. What does he like? Okay. All right. And it's going to still continue to what? Talk like a pirate. I forgot what it sense of it. There it is. So here he's talking about the boats, right? Galleons. Evidently, he's got a lot of preferences on the type of boat. Okay. But you get the general idea. However, if I went in here, well, I'm not going to change the temperature, but I could. With this system, I go in and change the temperature and all that kind of an experiment. So if I was going to use this API and I was writing a serious app, because it's set to 1, but if I'm doing something scientific or whatever, bump it back the other way. Physics, I might want to move it up to more creative. Okay, depends on what your job is. Right tool for the right job, right gas for the gas in the car, things like that. There's variety. Okay, going around, same thing. But get back to that. I have 400 plus models I can play with. Like I said, DeepSeek R1, R2 is out, and I can play with it. I go over to the chat, and actually I can do it in open other app on the machine. But since this one is geared towards trying out new models, so if it's flagship one, and I ask it a question, I can select different models to put there. Okay, I choose the models that go there, but I just hit one with the flagship say, and anyone got a question they want to ask 4 models at once? What's that? All right. Is a hot dog a sandwich? And did I type right? Oh. All right. Are we ready for the answer? So this is faster. These are the large versions of the model. These are the full ones that you would want to use if we were doing a commercial application. I'm using the API to go to. So what do we have here? So the first one, so it's reasoning, and this gives you other information. So it's reasoning, it thought for 27 seconds. You can see all that information on, in this case, Claude Sonnet 4, which is that one you like using in Cursor? Zarella? Sonnet 4 in Cursor, is that the one you're using? You're using Claude, but which one? You should, you have an assortment. For those who use Copilot in VS Code, because I pay for that too, you have a whole assortment. You can choose your different Claude. You know, they all have their specialty. So, but you can see what's going on there. So, because this is my research section, and I'm trying to find out what's the right model for the job. So, this is an old age question. Sandwich is actually a fun debate. It's not going to answer me, right? So, it's going to have a conversation. This one, short answer, it depends on how you define a sandwich. Somebody's creativity is up. Okay, you get the idea. It's a great philosophical. So the temperature is a little high in some of these. It wants to have a debate. Okay, but these particular guys, their temperature's set at that one range to be conversational. If I ramp the temperature down on these, which I can do in here in some of the cases, it could come back with an answer. Depends on how it was trained. But you get the idea. So let's break it down. I'm going to get a full analysis. So if we had the time to read these, it could lead to a very interesting debate. Oh, and I must have had a typo. I assume sandwich is a typo. Yes, points out my skilled typing. Okay, you get the idea. So Open Router AI, it cost me, what does it cost? And he threw $10 at it. Okay, so here's the cool thing: you could go play with this, throw $10 at it, one-time payment. All right. So if I go to here, because I want to give you things you can play with yourself. Wow. Because I made a point, out of that $10, I've only used 5 cents. Okay. In your sign up, you can go in and let's see, probably a couple days ago, because I wanted to try something that wasn't free. And it's better to pay for it because you get longer. So if I pay for it with at least $10, this is the catch, I could use nothing but free, which is what I've been doing in that open web UI that's on the computer. So I can point at open web UI and use these, and I can use these free ones. And there's different rates. That's all covered in the docs. In docs. And there's APIs to answer that question too. So if I click over here, rate limits, whatever. Let's do this. Let's go to models. So I have all these models here. There's over 400 models, but if I go free, if I go over here, better yet, these are all free models. Now I'm going to scroll this. So I can use these with that $10 in there and not really lose any money off of my $10, but I can go play with these. These are the latest. Chimera, the new DeepSeek, it's only been there a couple of days, and other DeepSeeks are there. Okay, but you go in here, you'll see there's little pricing, like it tells you your contacts. So like, here we go. Contacts on DeepSeek R1, which is free, is 164K. It's a decent size. Okay, it's not a million like GPT 4.1 million. However, used the API because it's a free one. I'm not paying for tokens. Okay, and I can build that into my application. Okay, experiment of doing an agent or whatever. So, but all that information is here, and you can dig deeper. You can dig deeper on Hugging Face. You can find all the scientific stuff that the data scientists notes, how they tested it. There's all these tests, like basically there's these tests for like if you're a PhD. So like Grok 4 supposedly qualified PhD level in 50 subdomains, I believe. So that would be medicine, physics, all planetary science, you name it, whatever domain is that you could take a test for at a PhD level. You could go in here, and in this case, I click on DeepSeek R1. What's neat about DeepSeek R1? So you can go in here and learn. If you do this, $10. If you stay with the free models, you're not spending any money. You can all afford $10. Just some of us just don't drink on the weekend. But you get the idea. You can go in here. You can go learn about it. Hugging Face is free. You can go learn about this stuff. You can learn about all the different models over in Hugging Face because there are different things you do, like when you do you can do what's called RAG data. So you could take all these manuals. So everyone know what Code Complete is? No formalized trained programmers here? A fantasy? You're talking to somebody who's met some of the people that wrote those books. Steve McConnell, Software Survival Guide. Yes, I go way back. Okay, but yes, I actually, in my attempt to make Mini-Me which I haven't called mini-me yet. Back, you saw it, super with this, architect that. I have fed using RAG into chat LLM. Let me show you that. Here's one of the advantages of paying for chat LLM. These are models you can use commercially. But if I go back, let's take a look at Ron RG Architect, Super Ron. All right. So if I go here, there's a little secret sauce going on in the chat LLM and Abacus AI, if you let me in there, where I can go in and set up knowledge bases. Now, these knowledge bases are actually, I have used Python. I've used certain things in Linux, like httrap to go rip a website down, all the documentation from a website, crunch it, tokenize it, and figure out how many tokens are in it, and build knowledge bases to add here as a document. Then it gets put in a feature group, and then I get it assigned in a document retriever, and there's a lot of things. There's all these other LLMs that get patched in. The way they do the interface, you don't know it's an LLM, but it is. That's a whole other area. But there's different LLMs that just take sentences and reduce it, or take paragraphs and different things. And there's custom ones. I'm using the open AI ones here, and it takes and shreds those and gets them ready with their secret sauce, and then I can train the model. Okay, once I train the model, or I can retrain the model, then I can go in and deploy it. But in the process of it is I created a custom bot. I can create a workflow, or I can create a chat bot, like ChatGPT. Only now it has the knowledge. So I've got books over here in the code and knowledge base. There are certain software architecture courses I've taken through the years, special training I did at American Express. I've taken a lot of commercial courses, okay, through the years, and I've condensed what I think is the best, including clean code. That book is in here under the coding knowledge base. So is Code Complete. So is a bunch of my notes in my attempt to make a mini-me chatbot. So now it knows how I code, and I can throw it code in my style and say, the hell did I do wrong? Or where is it? I don't see it. It'll go, hey, it's right here. That kind of thing. That's my attempt to clone myself. So it's like I did. I had children that didn't work the way I wanted. You get the idea. So that's one of the reasons I pay for this, and that's $10 a month. But it's $20 a month for the added stuff that I'm doing here. Okay. So chat LLM, if you actually want to do some serious stuff. I use chat LLM, chat GPT. At some point, I'm going to stop paying probably I'm waiting to see how chat GPT, you know what I mean, 5 is going to work. Okay. Eventually, I want to build equipment and take these models on my own and have them there running behind Open Web UI, Docker on a server. At the very least, I'll either do that and I'll start using these other models and their API because they're the full size model. If I get two 24 gig GPUs and put them in a box, the higher caliber models, I won't be able to run in it like I can accessing the API here. And when you start looking at the pricing of these things, it's like, I really don't need to do that. Why would you want to stand one up at home? I mentioned Terry, one of the network guys I follow, another epic hacker, the whole thing. He has 5 girls. They're homeschooled. But he built with 4 GPUs in it. But he also has a business. He runs out of the house, a couple other network guys and all that. He's got one that's trained or set up. He's set up in the prompt, and I didn't get into prompting. That's a whole nother course we could probably do, where it gets in there and he's got certain model. I don't know which one he's using. It might be Phi or one of those that's good for teaching. And he's got it set up where it's not supposed to give her the answer. It's set up with the system prompt for the only one she's allowed to access, or the girls are allowed to access for school because his wife homeschools them. When she gives them a question, they go research it and it's going to force them to learn it. Like it'll come back with questions so that it's not giving them the answer, it's going to lead them to the answer so they actually learn it. I thought that was pretty cool when he demonstrated it. Okay, but that's something you could do. That's something you would want, I would think. I would have wanted it for a few of my little Rugrats before. So Rugrats, yes, this is why there's a code of conduct. So please excuse me. But yes, I'm into all the slang. I was in the Marine Corps, so yes. But yeah, so that's that. I've did my time, right? Questions? Yes. Because you know me, I could go on forever. Yeah, in the back.
You know how many layers are in these systems?
It all depends. Each one. So if you use a thing called LLM Studio, which I almost showed last one. LLM Studio is another tool. I have it on here, but I'm not going to show it. Where I can tell it to try and get X amount in the CPU based RAM, the computer's RAM, and how many layers it can put in. So a model might have 50 layers, a model might have 80 layers, a model might have 141 layers. It depends on the model. And that's talking, the ones I've seen do that are quantized models where you might, if I had a desktop with 24 gig GPU in it, I would have to, hopefully I'd have like another 96 or 100 RAM and then I could do it, but it still slows down. Okay. It just gets a little faster than if you were 100% CPU. So there's a lot on the hardware side to learn those too, if you were going to go crazy like me and want to build this up.
But when you talk about loading that file onto RAM, are you talking about the RAM on the motherboard or the virtual RAM in GPU?
So RAM on the motherboard. Virtual RAM is, when I say GPU, I'm referring to the virtual RAM and the GPU. And it varies. My laptop only has 4 gig in it. And it's using some of it for other stuff, obviously. And right now, most of them, all the models are trained using NVIDIA GPUs based on CUDA tensors and stuff like that. Okay. There is work being done on the AMD side. Obviously, NVIDIA's come out with their first ones, things of that nature. So yeah, I keep telling my immediate bosses, if anyone comes and says, we need to stand up our own AI, I've done the research. This past weekend, I watched Home the Server, because I started in hardware decades ago, hardware and the whole bit. And they go through the types of servers where you can put in these various GPUs. You know, rather than build a desktop, there's stuff, because you can get GPUs with 80 gig on them. The A100, the H100s. I think there's an H something series where it has like 140, 141 on it or something like that. VRAM. And you'll see these servers where they're wrapped up, a server box where you have 4 and 4, room for a couple extra network cards. Because remember, you still got to move that amount of data around. So now we're talking servers with networks with 10 gigabits, this and that. It's a whole nother world out there to make these things run. When they started out, GPUs melted down in the cloud. Yeah.
So do you think they're databasing on that? So they,
Huh?
when you create a context, you think these companies, LLMs are
No. So they're using the server racks I described, where we're talking hundreds, thousands of GPUs set up in such a manner on the server to do all that. And to give you an idea, state that. Yeah, no, stateless. There are things you can do to keep it. There are things you can do like chat So you have projects. It keeps it, you have stored session stuff. It's yours. Okay. So yeah, if you go out here to Hugging Face, you see these data sets. A lot of the open source data sets that are used to train the models are here. So if you really want to learn, you just start banging around in Hugging Face and those other sites. And I'll make sure all these links get to Zarella and up in Discord. Okay, but to give you an idea, let's go to models real quick and then we'll end this. So if we go to models right now, Hugging Face has 1,855 plus models. See it up there in the top? It goes up every day. Last meeting, it was like 1.6. There's a lot of research going on and it's all getting dumped into there. You see there's different types of models. Look, transformers, diffusers. That's a visual thing, the diffusers. Any of you graphics people, stable diffusion, mid-journey, stable diffusion type vision models. There's all kind of stuff there. Okay. So best thing is to go out there and just start reading. Eventually it starts to come together. Am I using a hypervisor? No. I'm running some things in Docker. I'm a Docker person. So the LLM, no, I'm using OpenWeb which is running in Docker. And then I have models right here in Olama. And some of these I can't use. See that 4.1s? I can't load those on this machine. Now, hypervisor is different. We're talking virtual machines and stuff like that. I'm using Docker containers versus virtual machines. If you were at my last presentation, I would have shown you virtual machines, had I could show you here now, but we don't have time for that. I actually have Cloudflare tunnels to each of my applications. And I can actually RDP through any system to get to my servers at home because I have a full penetration system at the house, part of my training, in a separate isolated network. So I can go through my firewalls with Cloudflare tunnels into my main server to the virtual machines on another virtual network that's isolated so that nothing gets out or gets in. Yes. There's always an exception to the rule. So if you're using ChatGPT and you use projects, they save that stuff. So I have like 20 some projects in ChatGPT. One's AI studies, one's security this, one's database this. And all those conversations and the previous prompts and their responses are kept there. But I pay for that. It's part of my ChatGPT.
Data afternoon court order dated May 20th.
Yeah, so there's stuff going on everywhere. You know, some people say they're not doing this. Some people say they're doing that. You know, there's a lot going on. A lot of the stuff we're coming out is what was used to train the model. Initially, most of these models, they would go out and crawl the internet. They would crawl the internet like I did. I mentioned using HT track and just pulling down documents from different websites, like the documentation. I use Open Web UI, and I got tired of reading the documentation, so I pulled it all down, put it in a knowledge base, stuck it in ChatGPT as part of the knowledge base. So now that one GPT is just for asking questions. How do I do this in Open Web UI? I don't want to go read all the documentation, but I know what I want to know, and I can ask it. It's a great way to keep from reading the book. Call it live Cliff Notes, you know, but that's a good reason. So it's a 10x, if you do it right and you learn it, it's a 10x multiplier for what you do. So every programmer, it becomes a 10x multiplier for them, which is why a lot of them are all interested in it. But if you use it correctly, you learn this stuff, and I'm going to start closing these down, but you get the other one. I forgot to stop it. Okay,